Okay, everyone, welcome back to the video lecture series for Intro to Geographic Information Systems. I'm Andrew Foyce, Assistant Professor of Geospatial Science, and today what I want to talk about is something called map algebra, right? And so hopefully we all already know how to do algebra. So what we're going to basically learn how to do math with rasters, right? And so it's going to be very similar to how we do standard algebra, except instead of having variables, we have different raster data sets that take those places. So for example, if we were to do standard algebra, we might have something like A plus B equals C, right? It could be a lot more complex. And if we knew one of these variables, we could solve for the others. Those things still apply. But basically what we're trying to do is to leverage a tool called Raster Calculator to do computations like A plus B equals C, except A becomes a raster, B is another raster, right? Raster 1 and raster 2, and we can add them together to get a whole new raster output, okay? And so there's a lot of different applications for this, one of which you guys probably learned with the Solar Lab, where we do raster overlay operations, right? So we've already learned how to do vector overlays, which take a bunch of different polygons and lines, put them together, and we can do things like see where things intersect, where they overlap. We can do operations like erases and clips, and merges and unions and all sorts of other things by combining different vector layers. Here, we're going to learn how to combine different raster layers using Raster Calculator. So as I said, we can do math. A simplest example of math is you right here maybe using something like elevation data, right, where we have a raster with a bunch of cells, and inside those cells we have values that represent the elevation, and maybe this elevation is in meters. Well, you may be doing some sort of operation that basically requires your elevation data is in feet, and so one very easy way to convert your values in your cells to a different unit is to simply multiply by a conversion factor, right? The conversion factor will change depending upon which units you're going by, right? But very simple. Take the raster, multiply by a number, and then out comes a new layer that's in feet instead of meters, right? We could also just do something simple. Maybe our elevation data for some weird systematic reason was off by 100 feet. We could go in and make that adjustment by doing raster layer plus 100 feet. Then every value would increase, right? So we can manipulate the values in the raster layer using the Raster Calculator, which allows us to effectively do map algebra. And there's a whole lot of different functions in there that you can use. There are all sorts of trigonomic functions. There are different types of transformation functions, and the list goes on and on. So you could use something like the log or the cosine, or anything like that. You could do exponential things, right? So very, very useful tool. Now, in terms of the lab that we're working on, we do something a little bit unique in there, where we use the Raster Calculator to combine or to overlay different layers together. And for this sort of operation or logic to work, we have to treat things as Boolean objects, right? Or use Boolean logic. And so Boolean logic says things that are yes equal ones, and things that are no equal zeros, or this could also be false, and it could also be true. And so in the Solar Lab, what we're trying to do is create or identify places that would be suitable to put a solar wind farm. And so we have several different factors, one of which is the amount of solar radiation. The other is the current elevation, two things that affect how much solar radiation we receive, or insolation. And so what we have to do is we have to interact with the raster layer and extract what it is we need. So for example, if we wanted the elevation to be over just, let's say, 1,000 feet, we would go to Raster Calculator and say, hey, raster, whatever the raster is, this is just a generic name, and we might say, hey, we want it to be greater than or equal to 1,000, okay? And what that's going to generate is a brand new layer where everywhere that is below 1,000 feet is a 0, and everything that is above 1,000 feet or equal to it is a 1. Okay, and this is referred to as the grid code of that raster layer. So if you ever convert a raster into a polygon, there will be a field called grid code that has retained the cell value of that raster. Okay. Then we may have a second raster, which maybe is the amount of solar insolation, and we may say, hey, this has got to be over 400. And again, we get a second layer. So here we have 2 layers, 2 rasters that are now Boolean, where there are 1s representing places that meet the criteria and 0s that do not. And if we wanted to do a very simple overlay and find places where both of these factors occurred, we would simply say raster 1 plus raster 2, and then we would add this value to this value, this value to that value, this one to this one, and that one to that one, right? It's almost like matrix algebra, where we have a bunch of arrays on top of each other, and we're doing math in between different positions. So the result of this would be a new raster where we have a 1, a 2, a 2, and a 2. So it's pretty simple. So we can basically identify which cells meet all of our different factors or how many they make. And so if we had a 4-factor model and we wanted places or to find places where all factors or conditions were met, we would go then to our result or our resulting raster and do another raster calculator operation where we would say, hey, raster is greater than or equal to 4. And this would again give us 0s and 1s, where all the 1s were a value of 4, which is true. Okay? So there are tons and tons and tons of different applications or different reasons why you might want to use raster calculator. Another more complicated example could be a regression model that you created in some sort of statistical software package, and you had different layers that represented different variables, and you could basically build out that regression equation in the raster calculator, which would then produce a predictive surface for whatever your regression model was attempting to predict. So very quick primer on map algebra, but it's very flexible. It allows us to do conditional statements, asking for criteria, which gives us Boolean. And it also allows us to do math, basically using any equation that we can think about. That's all for this very brief lecture today. I'm going to post on D2L a Dropbox where I want a very short write-up where you explain what the map algebra tool does. Thanks.